moving from this picture to a more complete picture, we have this. Now here's our delta y by delta x rectangle. Here's our point x naught, y naught. We've chosen to move in the negative x direction and the positive y direction because those are the directions that will both give us positive changes in our function value, give us positive changes in our z value. Now, delta x is in this direction, so we're going to say here, we're just going to write this out, that delta x is negative, since it's going in the negative x direction. And we've written down the f of x, y function and its derivatives just as a reminder. Fx, the x derivative, is negative, so that when we multiply fx by delta x, we're going to get a positive value. So we have our positive change in the value of z. And I labeled that delta z partial. I'm not going to label it any further than that because any notation I can think of is more confusing than just denoting it like this. The confusing thing is that I'm denoting the change due to the y by the same symbol, but these are actually different. Now, if I move in the positive z direction, of course, I get my change fy delta y, where fx and fy are both evaluated at the point x naught, y naught. These changes are, if you will, built on the value z naught equal f of x naught, y naught that we got at the point x naught, y naught. So that as we move in the x direction, we add this delta z to the value z naught that we started with. Similarly, as we move in this direction, we add our delta z for the y direction onto the original value of z, the value z naught equals f of x naught, y naught. If we consider where we are then in the xy plane, if we've moved this negative delta x, and we're back here for our x coordinate, our y coordinate will be y naught plus delta y, and we're going to be at this point. Our value of z at this point will be greater than our z naught by the amount delta z here for the y component, and that's fy delta y, that's this distance here, that's this difference, and also by the contribution of our fx delta x. Our total change in the value of z, or in the value of our function f, is from the original value f of x naught, y naught, to the final value f of x naught, y naught plus fy delta y plus fx delta x. So here's our delta f, and it's equal to fx delta x plus fy delta y. I'd write that out, but don't really have room to do that. Okay, maybe I do have room to do that. I'm going to have to make room to do that because it's important. What we see here is that delta f equals fx delta x plus fy delta y, and this is not a strict equality. We'll call it an approximation because, of course, this triangle is not necessarily similar to this green triangle. The way I've constructed it, it is, but if we go to the actual value of the function, the slope will very possibly change a bit as we move in the y direction. The slope in the x direction will probably change a little bit, but as long as, again, the delta y and the delta x are small, the change will be slight, and this approximation is going to work.